Hello friends, in this video we will study about the various data transfer instructions like move, in and out, push and pop and exchange instructions which are available in the instruction set of 8086 microprocessor. Data transfer instructions are those instructions which transfers the data from one position to another position. Okay, so from one place to another place, if we want to transfer the data or we want to move or copy the data, then we use these data transfer instructions. So these data transfer instructions, they are basically used to transfer the data. Now this data transfer takes place from a source place to the destination. That is, the data is picked from the source place and then it is copied or transferred to the destination place. Okay, so source and destination, they are the two places. Now these two places can be either a memory location or a register. Okay, so the data transfer instructions, they are used for transfer of data from memory to the internal register. Means memory will be the source and internal register will be the destination. Also from the internal register to memory, so in this case internal register will be the source and memory will be the destination. Then from one register to another register, means between the register also, if we want to transfer the data, then also we can use the data transfer instructions. Then from input port to the internal register, if the microprocessor it wants to read some data from the input port, then that data will be transferred from the input port to the internal register. So that is, input port will be the source and internal register will be the destination. Similarly, if the microprocessor it is sending some data on the output port, so destination will be the output port and source will be an internal register. So here in these transfer of data, we have the two places, source and the destinations. Okay, so there can be different places for it. Now in these data transfer instructions, depending upon the source and the destinations, which either memory is chosen or the register or an internal register or input port, output port. So depending upon it, we have the various data transfer instructions. In this we have, first is the move instruction. Second we have push and pop. Third we have in and out. And fourth we have the exchange instruction. So these four instructions, they come under the category of data transfer instructions. Let us study these instructions one by one. First we will start with the move instruction. So this move instruction, it is used to transfer the data between register to register, from memory to the register, from register to a memory location, or with the immediate data. So here the transfer of data takes place. The data is not transferred, it is just copied from the source to the destination. Okay. So this instruction, when the transfer of data takes place, means the data from the source, it is copied to the destination. So the source and destination, they need to be of the same size. It means that if the source is having a data which is of 8-bit, then the destination place should also be of 8-bit, so that that data can be transferred. Also, if source is of 16-bit, destination should also be of 16-bit. So the size of the source and the destination, they have to be equal. This move instruction, it does not affect any of the flags in the flag register like carry, auxiliary carry, sign, parity, zero, overflow. All these flags are not affected due to this move instruction, because no changes in the data is taking place, only just it is copied from one place to the another place. So it does not affect any flags. Now let us take some examples of this move instruction. This instruction move bx comma 00f2h, it is transferring this immediate data into the internal register bx. So this 00f2h, it is a 16-bit data, and this is transferred to the base register bx. Bx is also 16-bit register which is having bh and bl, the higher order register and the lower order register. So 00 will be stored here and f2 will be stored in the lower byte. So here the size of the source and destination, you can see that it is same. It is a 16-bit data, so the destination is also a 16-bit. Okay, and this type of addressing where the immediate data, it is available in the instruction itself, that is the immediate addressing mode. Next example we have for move as move cl 2000h. So here in this instruction, the data which is stored at a memory location, that data will be transferred to the CL register. CL is the lower order register for the count CX. We have CH and CL. This is the count register. It is also of 16-bit, but it can be divided into two 8-bit register, higher order and lower order. So CL here, it is an 8-bit register. And 2000h, it is the effective address. So this address 2000 will be added into the data segment address, that is segment address, multiplied with 10h. That will be the physical address of the memory location. So that memory location, the 8-bit data is stored, so that 8-bit data will be copied into the CL register. Okay, so here we have indirectly given the data, so it is a type of indirect addressing. Okay, next type. So this is the transfer of data between a register and a immediate data. Here we have taken that the transfer of data is between a memory location and a register. This is between the register and the memory location. Source is the register and destination is the memory location. So 589, it is also the effective address that will be added into the data segment address, and then the physical address of the memory location will be obtained. So the data, the 16-bit data which is available at this in this register, base register, that will be copied into the memory location. Okay. Next example we have is move DS, CX. So in this, CX is a 16-bit register. Data segment is also a 16-bit register. So the contents of this register will be copied into the data segment register. Okay. So this is the transfer of data between two registers. So the move instruction, it is transferring the data between register to memory, memory to register, and also from an immediate data to the register or immediate data to a memory location. Between the register also it is transferring the data. So data is just copied from the source to the destination. Okay. Next type of instruction we have is the push instruction. Push and pop instructions, these two instructions are used to store or retrieve the data from the stack. Whenever we want to use the stack to store some temporary data, then we use the push instruction to store the data and pop instruction to retrieve the data from the stack. Now let's see that how this push instruction it executes. Now the push instruction, it is used with the stack. So whenever the stack is used, it is always initialized to a memory location. So this initialization of the stack, it is done with the help of the stack pointer. Okay. So stack pointer, it points to the beginning address from where the stack is starting. So suppose we have initialized the stack. So the stack pointer, it is going to point at this memory location. Suppose we have given here 30,000 H. So stack is going to store the data through this push instruction into the stack. So first it is going to decrement the stack pointer by 2 and it is going to copy the word from source to the location where stack pointer now points. So this push instruction, it is first going to decrement the stack pointer by 2. So this is stack pointer, this is stack pointer minus 1, this is stack pointer minus 2. So it is going to be decremented by 2. So now the stack pointer is going to point at this memory location. So the data is going to be stored first at this memory location, then this, and then this. So in this way, the data is stored in the stack. Let us take an example so that it will be more clear to you. Push CX means CX is the count register. The contents of the count register, it will be a 16-bit register. So that will be stored in the stack. So suppose we have initialized the stack pointer at 0034. That is the stack pointer, and we have the stack segment because the stack is stored in the segment which is known as stack segment. Okay, that segment is assigned for the stack only. So stack segment is initialized at an address 3000. Okay, so 3000, this stack segment, it will be multiplied with 10h, and then this will be added with the stack pointer. So the address we will get is 30,000 plus 0034. So we are getting 30034. This is the address. Now at this address, the stack is initialized. Now push instruction, it is going to decrement the stack pointer by 2. So first it will be decremented to 0033, then it will be decremented to 0032. So now the stack pointer, it is pointing at the memory location 30032. Now contents of the CX register, it will be CH and CL. CH is, suppose it is having 20 and CL it is having 30. Okay. So first the lower order register will be stored at 30032. Again it is going to be decremented, and then the higher order register will be stored. So here 30 will be stored, and here 20 will be stored. So whenever this push instruction is used, the stack pointer, wherever it is initialized, it is decremented by 2, and then the contents of the source register, that will be stored in the stack. Okay, so always remember that you have to decrement the address by 2 in the case of push instruction. Next instruction we have is pop. Pop instruction is used to retrieve the data from the stack. So whenever we want that we want to get the contents of the stack, we use the pop instruction. The execution of this instruction, it is similar to the push instruction, but in the case of push instruction, the address is decremented by 2, whereas in case of the pop instruction, the address is incremented by 2. Suppose, taking the same example, we were having this was the memory location where the stack was initialized. Then stack is decremented to the memory location 32. Here the lower order address 30 is stored, and here the higher order address 20 is stored. Now if we want to get this data, we will write here pop CX. Means we are going to pop the contents of the stack and we are going to store it in the CX register. So first this 20 will be taken out and it will be stored at CH, and then 30 will be taken out and it will be stored at CL. So in this case the addresses are incremented. Okay, so that is the difference between push and pop. So this pop instruction, it copies the word from the stack location which is pointed by the stack pointer, because now the stack pointer is pointing to this memory location. So from this it will be copied into the destination, and when the content is copied, the stack pointer is again decremented by 2. So now the stack pointer, it is going to point at this memory location. Okay, so this is the pop instruction. Push and pop are used in the case of stack. Next instruction we have are the in and out instructions. These instructions are used to transfer the data from the input and the output ports. So here this data, it is copied from the port address 0F8 because the ports there are 256 input output ports in case of 8086. So their addresses will be from 000 to FFF. So here we have the address of one of the port, that is 0F8, and the data which is there at this port will be copied into the AL register. Okay, then we have IN, AL, comma DX. Suppose after this we have written an instruction move DX, comma 03F8H. So this will be copied into the data segment register, that is data register DX, and then DX will be copied into the accumulator register. Okay, so here that 8-bit data will be copied from the location. First that data will be stored into the DX, and then DX will be copied into the AL register. Okay, for out similarly we have out. So here the contents of the lower order accumulator register that will be stored at an output port whose address is 047H. Okay. Again here also we can have an indirect addressing also. First we are going to store the data in the some register, and then that register will be copied onto the output port. So here in this way you can see that the data, it is copied from the input port to the accumulator, and out instruction it is copying the data from the accumulator to the output port also. Now here also no the flags are not affected because just the transfer of data is taking place. Next instruction we have is the exchange instruction. Exchange instruction, it is used to exchange the contents of two locations, like between register to register also, and from register to memory location also it can exchange the contents. So this instruction, it exchanged the contents of the destination and the source. Now here the destination and source, it can be register and register, their contents can be exchanged, and register and memory location, their contents can also be changed. But the exchange instruction, it cannot exchange the contents of two memory locations. You can see here that the source and destination, I have not written that between two memory locations it is exchanging the contents. So it is an exception that the exchange instruction, it does not exchange the contents of any two memory locations. So this exchange instruction, it basically exchanges the contents of the source and the destination. Let us take some examples here. So these are some of the exchange instructions. In this first instruction, the contents of the BX and the CX register, they are exchanged. Both these registers are 16-bit registers, so their contents can be easily exchanged here. Now exchange AL and CL, both these registers are 8-bit registers, so 8-bit content can also be exchanged. Just keep in mind that the size of the source and the destination, it is same, because a 16-bit data, it cannot be exchanged with an 8-bit data. So here 16-bit data are exchanged, here 8-bit data is exchanged. Now here we have exchanged the contents of the AX register with the contents of this memory location. This memory location, its address is obtained by adding the data segment address DS, multiply it with 10H plus the sum, which is the displacement provided in the instruction, plus this BX register contents. So this is collectively forming the physical address of the memory location where the data is stored. So that 16-bit data will be exchanged with the AX register. So here you can see that the contents of the source and the destination, they are exchanged. The source can be a register or a memory location, and destination can also be a memory location, but to exchange between two memory locations, it cannot be done using this instruction. So here in this video, we have studied about the data transfer instructions: move, push and pop, in and out, and exchange instructions. These instructions are used whenever we want to transfer the data from the source to the destination. So I hope that this topic is clear to you. Thank you.